Today, we'll be talking about kinetic friction and static friction. So let's start off with some very basic points: static friction and kinetic friction. The simplest thing you can know about them is that static friction is usually higher than kinetic friction, and kinetic friction is usually lower. So what is friction? Well, if you drag your hand against any surface, you're going to feel some amount of resistance that the table is pulling back onto you in the opposite direction of your movement. So friction just resists movement. They're usually going to be represented by mu of S for static friction and mu of K, started by kinetic is K, static is S. Now, these coefficients are usually some decimal number like 1.5 or 0.8. Kinetic friction can be 0.1, 0.7. But usually, if you were to compare them, let's say for a surface, there's a static friction of 0.15 and there's a kinetic friction of 0.1. Usually, the kinetic friction will have a lower number within the same surface. And I Google searched this, interesting fact, but the highest static friction ever recorded was 3.0, which is ridiculous. It's some type of weird rubber, but that's off topic, of course. So how do you calculate the force of friction? Well, you know free body diagrams. You can draw out all the forces and everything like that. But you can actually represent friction as one of the forces. So if this is F push, this is F push, this is normal force, and this is weight force. You can actually represent friction as one of the forces, usually with lowercase f. And how you could calculate this is multiplying your normal force by the friction coefficient. The mu is the friction coefficient. And then you will get the force of friction. So keep in mind, in order to move something, you need a net force of more than 0. Correct? Well, if you have, let's say, a box, it weighs 10 kilos. The weight force is therefore 98 newtons, and the normal force is also 98 newtons. Let's erase this. Since the normal force is also 98 newtons, you would multiply 98 newtons by the friction coefficient. Let's say the friction coefficient in this case is 0.1 for static friction, non-moving. So your total force of friction or static friction is 9.8 newtons. But here's the thing. If you were trying to push the box in this direction with 9.8 newtons, friction, so let's say this is F, friction will push back with 9.8 newtons, static friction, at maximum. So net force would in total be 0. But if you were to push with a force of 8 newtons, then the force of friction would also be, the static force of friction will also be 8 newtons. Because if the static friction was 9.8 newtons, this box would be accelerating in the direction of friction, which doesn't make any sense. So the static friction, if an object at rest, will always be the same as your push force or pull force. Now, what happens if we go past this 9.8? Let's say the kinetic friction in this case is 0.05, because the kinetic friction has a lower coefficient than the static friction usually. Oh, I need to remove the 8 newtons here first. So mu of K is equal to 0.05. The moment your push force goes past the static friction, so if static friction is trying to resist with 9.8 newtons, what if you push with 10 newtons? Well, the moment that happens, this box is moving. And when the box is moving, kinetic friction goes in. So you don't use the static friction force anymore. You use kinetic friction. So you multiply the normal force by the kinetic friction coefficient, and then you get 4.9 newtons. Now the resistance is just 4.9 newtons. So before, the static friction force pulled back with 9.8 newtons until you reach past 9.8 newtons at 10 newtons. And then once that happens, the box is moving, and that's when kinetic friction takes over. That's one of the harder points to calculate for and to keep in mind all the time. But once you get the box moving by overcoming static friction, you will then use the kinetic friction coefficient after the box starts moving to multiply with your normal force to get the force of friction when the box is moving. So in a free body diagram, if the box wasn't moving, then the weight force, normal force is balanced here, and the push or pull force is equal to the friction force. But once the force of push is greater than the friction force, static friction force specifically, then static friction will be completely removed. This arrow would probably get shorter because kinetic friction is less than static, and you would use kinetic friction. So once the box starts moving, you use kinetic friction. When the box is still, you use static friction. So if I'm just going to add a little bit of nuance to this, I don't think I need to erase this. If I'm just going to add a little bit of nuance, the only time static friction applies is when a surface is slipping against something. So when you're sliding against something, like this box is sliding against the floor. But when it comes to a wheel rolling, when a wheel is rolling, unless if it's a very greasy and oily and baby oiled up surface, then this wheel is not using kinetic friction in order to roll. It's using static friction because this wheel is technically, there's no slipping going on. If this wheel just didn't rotate at all and it was moving in this direction, then this would be using kinetic friction. Kinetic friction would be active. But if the wheel is rolling, well, technically the part of the wheel that is making contact with the surface, if you zoom in super close, it technically isn't sliding. So when you're using wheels, unless the question specifies that it's sliding, which most of the time in a level 1 mechanics course it won't, unless it specifies that the wheel is sliding, usually the force of friction is going to be using the static friction coefficient, not the kinetic. So that's it for the video. As always, if you have any questions, put it down in the comment section. I hope this video helped you guys.